Okay, scientific notation. So definition of a scientific notation or definition of a number written in scientific notation is a way to write numbers using a power of 10, which our number system is based on. A number expressed in the form a times 10 to the n power, where a that I'm pointing to must be between 1 and 10. And n is an integer, meaning the integer can be positive, negative, or zero. It's said to be written in scientific notation. So scientific notation is usually usually used to express very large or very small numbers. So here are two examples of scientific notation: 7.54 times 10 to the seventh, and this would be your A, the decimal part. It says a number that is less than 10 but at least 1. So we have three parts to scientific notation. Then we have part 2, our times and then our base 10. And then our part 3, which is the end portion, exponent, which may be positive or negative. So what we're looking at today, we're going to look at how to convert a number in scientific notation, and then how to take that scientific notation and write it in reverse order, which is standard notation. So we have here, to write a number in scientific notation, locate the decimal number. Okay. And then it says move the decimal point. The it means the decimal point to a location that will give you a number between 1 and 10, or exactly 1. Write this new number down, followed by the times 10. Count how many times you had to move the decimal point. Use this number as your exponent. And then it says decide the sign of the exponent, which number 1, if the number is large, or when the number is large, make the exponent positive. When the number that we're looking at is small, that we're converting, we're going to make that number negative. So we'll come back to writing a number in standard notation, but let's look at a number that we're going to write in scientific notation. So let me adjust this. So for example, 11,320,000. We want to write this number in scientific notation. Well, the rule says locate the decimal point. When there is no decimal point, the decimal point is understood to be after the last digit. Here's our decimal point. And then it says move the decimal point to a location that would give you a number between 1 and 10. So we want a number between 1 and 10. So we can't put the decimal between this 1 and 3 because that's 11. We can't put the decimal point between the 3 and the 2 because that is not between, we will have 113.2, and that's not between 1 and 10. So we will have to move the decimal point between the two ones. So let's count over. 1, 2, 3, 4, 5, 6, 7. So this arrow here that I'm drawing indicates this is where we're going to place our new decimal point. And that gives us 1.132. And 1.132 is between 1 and 10. So we're going to write down this new number, 1.132, followed by the times, and 10 to the, we moved 7 spaces, or we can say places. So we moved 7, and because the original number is large, meaning it's greater than 1, then our exponent is going to be positive. So we have here 1.132 times 10 to the 7th. Example B, we have 0.00052, and we want to write this number between, we want to write the decimal between 1 and 10. Okay, so write this decimal number in scientific notation. So here we have our decimal point right here, and we want to move this decimal point to a location that will give you a number between 1 and 10. So let's count over. 1, 2, 3. Now, if you stop here, that's 0.52, and 0.52 is not between 1 and 10. So we have to move over one more space. And we moved 4 spaces. So we have here 5.2 times 10 to the, because the original number is small, our exponent will be negative. So our solution is 5.2 times 10 to the negative 4 power.